Very good morning to my dear students. First of all, I welcome you into my YouTube channel and Talukdar Maths. Okay. So, in continuation of my lectures regarding the topic complex number, today I am continue with this particular topic again, and I am going to discuss about few very important concept regarding complex number, which will be very useful in solving the questions. Okay, so I hope you will concentrate in the class and understand every concept, every content of the particular video. Okay, my appeal to all of you, watch the videos thoroughly such that you can understand. Mathematics is a practical subject. It should be watch the video in thorough manner, otherwise it will be difficult for you to understand the basic idea concept. Okay, when your basic will be strong, definitely you will excel more in the subject mathematics. Okay, so this is my advice to all of you, and let us start with the topic with these some properties. First I am going to discuss about properties of conjugate complex number. Already we have discussed about what is complex number and what is its conjugate complex number. Okay, and regarding this we are going to discuss about some properties. Okay, the first, you see, there are major three properties are there. That is, suppose Z1 and Z2 are any two complex numbers, कोई भी complex number हो, then Z1 plus Z2 bar equal to Z1 bar plus Z2 bar, or Z1 minus Z2 bar equal to Z1 bar minus Z2 bar. That means if you sum of any two complex number, if you अगर आप उसके ऊपर एक बार लिया करें, conjugate लिया करें, then what happen, it will be conjugate will be separated. Conjugate will be what? Separated. Conjugate क्या होता है? Separate हो जाती है. ठीक है. Here I am taking two complex number. You can take more than two also. Suppose Z1 plus Z2 plus Z3. Then what happen? You can write Z1 minus Z2 minus Z1 bar plus Z2 bar plus Z2 bar in this way. If you take n number of sum of n number of complex numbers, suppose Z1 plus Z2 plus dot Zn whole bar is equal to Z1 bar plus Z2 bar plus dot up to finally Zn bar. You can distribute it. So this is the property. Again, the second property is if product of any two complex number, if you take the bar of this product, then bar can be separate. That means conjugate can be separated. Z1 Z2 conjugate equal to Z1 conjugate into Z2 conjugate. ठीक है, ये है property. In particular, this particular result can be illustrated, can be analysis. In particular, if Z1 and Z2 are same complex number, इसमें ये प्रॉपर्टी इतना यूजफुल नहीं है, लेकिन अगर इसमें क्या है सेम हो जाए तो उसमें और नया एक प्रॉपर्टी निकल के आती है. That's why I am taking if Z1 and Z2 are same, both are equal, and suppose that it is equal to what? Z, a particular complex number. Okay, then if you put Z1 equal to Z, Z2 equal to Z, then left hand side is what? Z1 into Z bar, and right hand side will be what? Z1 is replaced by Z, so Z bar into Z bar. So finally Z into Z equal to what? Z square. Z square bar equal to what? Right hand side क्या हो रहा है? Z into Z bar into Z bar equal to what? Z bar whole square. इसमें क्या रिजल्ट आ रहा है? देखो, Z square bar equal to Z bar whole square. That means what? When bar क्या हो रहा है? Square will out and it will be that is ये स्क्वायर क्या हो रहा है? Z बार के ऊपर आ रहा है, ये रिप्लेस हो रहा है. बार इधर आ रहा है, स्क्वायर इधर जा रहा है. ठीक है, सो Z स्क्वायर बार इक्वल टू Z बार होल स्क्वायर. ठीक है, ये एक फॉर्मूला है. सिमिलरली यू कैन से Z क्यूब बार इक्वल टू व्हाट? Z बार होल क्यूब. ओके, सिमिलरली इन दिस वे Z टू द पावर n बार इक्वल टू Z बार होल टू द पावर n. दैट मीन पावर जो होती है वो पावर कंजुगेट के ऊपर पावर हो जाती है. ठीक है, ये एक बहुत ही इंपॉर्टेंट प्रॉपर्टी है. यूजिंग दिस वी आर गोइंग टू सॉल्व मेनी क्वेश्चन. एंड इफ सपोज Z1 बाई Z2 होल बार, तो ये डिवीजन में है, देन इट विल बी व्हाट? Z1 बार अपन Z2 बार, प्रोवाइडेड Z2 इज ए नॉन जीरो कॉम्प्लेक्स नंबर. अगर Z2 जीरो कॉम्प्लेक्स नंबर हो जाए तो इट विल बी जीरो एंड इट विल बी अनडिफाइंड. ओके, इट विल बी व्हाट? अनडिफाइंड. So to make it define, what we have that is condition given, that is Z2 not equal to 0. It is not a zero complex number, it is a non-zero complex number. Okay, these are the properties. You can prove it this particular this. Suppose I am taking this to, ये तो proof करना काफ़ी easy है, या एक suppose इसमें एक proof कर ले. Suppose roughly I am going to prove it. Suppose Z1 equal to what, A plus IB, and Z2 equal to what, C plus ID. Okay, these are the two complex number. Okay, then what will be Z1 plus Z2? आप ऐड करेंगे तो क्या होगा, रियल पार्ट्स के साथ ऐड होगा, इमेजिनरी पार्ट के साथ ऐड होगा. इमेजिनरी पार्ट क्या है, B एंड D है, I कॉमन लिया करो, B प्लस D. ठीक है, ये Z1 प्लस Z2 हो गया है. इफ़ यू टेक बार Z1 प्लस Z2 बार, देन इसमें क्या होगा, इसमें भी बार होगा, A प्लस C प्लस I इंटू B प्लस D. ओके, दिस इज बार. ओके, I hope you are understanding. ठीक है, then what happen, since we know that it is a complex number of the type capital A, if you consider this is A and this is what B, this is of the type A plus IB. Okay, and what is the conjugate of A plus IB? It is what, A minus IB. Yes, what is A plus C minus I into B plus D. Okay, something this way, which equal to, suppose finally what happens, Z1 plus Z2 bar equal to what, A plus C, इसमें क्या होगा, माइनस होगा, माइनस I into B plus D. Okay, and from here you can write A minus IB plus C minus ID. Okay, you can write this, and which equal to A minus IB is what, that is if you take Z1 bar you will get A minus IB, if you take Z2 bar you will get what, C minus ID. That is A minus IB equal to what, Z1 bar, and C plus ID is equal to what, Z2 bar. So finally what we get, Z1 plus Z2 whole bar is equal to what, Z1 bar plus Z2 bar. This is the property. Similarly if you take minus here, you will similarly Z1 bar minus Z2 bar होगा. ठीक है, तो आपको शायद समझ में आ रहा है. You can prove it. I am not going to take Z1 into Z2. I have already shown you how to multiply that to complex number. So first what you will do, you will multiply Z1 into Z2. Okay, you can prove it. Sometimes question में आ सकता है, prove that this is equal to this if Z1 and Z2 are complex number. Okay, take Z1 is a complex number like A plus IB, and Z2 is a complex number C plus ID, and then find Z1 into Z2. Then find what, Z1 into Z2. After finding Z1 into Z2, reduce this Z1 into Z2. Z1 into Z2 निकालने के बाद आप क्या करेंगे, उसको A plus IB में कन्वर्ट करेंगे. ठीक है, और इसके बाद Z1 जब बार लेंगे तो उसमें बार आएगा, इक्वल टू व्हाट, A बार माइनस A माइनस IB होगा. ठीक है, एंड यू नो व्हाट इज़ A. आपकी जो प्रोडक्ट करेंगे, प्रोडक्ट करने के बाद एक A निकल के आएगी, B भी निकल के आएगी. तो पुटिंग A and B, then you can arrange it like this and you will get Z1 bar into Z2 bar. This is the assignment for you. Please prove it. You prove it, and you also this particular property Z1 by Z2 होल बार इक्वल टू Z1 बार बाय Z2 बार, ये जो डिस्ट्रीब्यूट हो जाती है, ये भी प्रॉपर्टी आप लोगों को प्रूफ करना है. ठीक है, प्रूफ करके, दिस इज द होमवर्क फॉर यू. प्लीज दिस इज द होमवर्क फॉर यू. सो सबमिट मी. दिस इज ऑल्सो होमवर्क फॉर यू. ओके, understood? And this property is this particular property I have discussed. It is very useful one. Okay, से जो पावर जो होती है, पावर क्या होता है, बार के ऊपर जाता है. तो Z क्यूब बार इक्वल टू Z बार होल क्यूब. बेसिकली दिस इज द फॉर्मूला. फ्रॉम दिस फॉर्मूला ऑल द फॉर्मूला विल बी डेवलप. Z टू द पावर n होल बार इक्वल टू what, Z बार होल टू द पावर n. कोई भी पावर हो तो ये पावर ऊपर में जाएगा. व्हाट इज n? n is an integral number, natural number, because 1 2 3 4 5 6 7 8 9 10 this way. Okay, so these are the properties I have discussed. Okay, and we are going to prove some important results regarding that is conjugate of a complex number. Very important results. These are the properties and which those who are going to discuss now, जो मैं डिस्कस करने जा रहा हूँ, ये बहुत ही इम्पॉर्टेंट है। ये प्रॉपर्टी भी कह सकते हो, ये फॉर्मूला भी कह सकते हो, और एक रिजल्ट भी, यू कैन से ए पर्टिकुलर रिजल्ट, इम्पॉर्टेंट पॉइंट्स भी कह सकते हो, ठीक है। So these points are very useful one. It will be used in the questions to solve the questions, okay. And the important results, you say important results. If z is a complex number, z is a complex number, then first result is number 1, z bar whole bar equal to what? Z. This is property, very nice. Z bar whole bar equal to what? Z. One by one I am trying to prove it, okay. Let's suppose z equal to what? A plus ib. Okay, what is z bar? Z bar means what? If you take bar, it will be what? A minus ib, conjugate, okay. Now take again bar, z bar whole bar equal to a minus ib bar. Now see, we know that when you take bar, this sign will change, माइनस होगा तो प्लस होगा, प्लस होगा तो माइनस, उसमें माइनस है तो कंजुगेट लेने के बाद क्या होगा? प्लस हो जाएगी, and which equal to what? Z. Hence proved. So z bar whole bar equal to what? Z. ठीक है, that means एक complex number को twice you take conjugate, you will return back to the again complex number. जो complex number कोई भी होगा उसको अगर दो बार conjugate लिया जाए तो आप original complex number में रिटर्न करेंगे, ठीक है। नंबर 2 is what? Z plus z bar equal to what? 2 real z. Okay, very simple. Here I have taken z equal to what? A plus ib. तो z bar क्या होगा? A minus ib, ठीक है। z प्लस z bar क्या होगा? आप ऐड करेंगे तो क्या होगा? ib कैंसिल, ट्वाइस a, एंड a मीन्स व्हाट? 2 रियल z. और फ्रॉम हियर यू कैन एनालाइज रियल z इक्वल टू, वेन एवर यू आर फाइंड टू रियल z, ये 2 इधर आएगा हाफ इंटू z प्लस z bar, ओके, अंडरस्टूड। Another property, that is, you say these are this particular results can be considered as a property also. Number 3, z bar minus z bar equal to twice I into imaginary z, okay. So same result you see, सेम रिजल्ट माइनस करके देखो, z माइनस z बार इसका क्या होगा? a प्लस आई बी माइनस a माइनस आई बी, ओके, एंड यू सी a कैंसल, आई बी माइनस में से प्लस, दिस इज इक्वल टू आई बी, एंड इट कैन बी रिटन एज व्हाट? 2 इंटू I into what is b? b is called imaginary part of the complex number what? Z. This is your, this part is called what? Imaginary part of z. This part is called real part of z, okay. So this is the result, z minus z bar is equal to what? Twice I into imaginary z. From here you can develop imaginary z equal to, ये twice I इधर आएगा तो क्या होगा? 1 by twice I into what? z minus z bar, okay. So imaginary part equal to what? 1 by twice I into z minus z bar. So from these two results, one result is imaginary z is equal to 1 by twice I into z minus z bar, Another is what? Real z is equal to half into z plus z bar. These are the two important results. From these two results, we are going to analyze and get a very important points. If star mark लिखो, if z is purely real, आप लोगों को लास्ट क्लास में मैंने बताया था व्हेन ए कॉम्प्लेक्स नंबर z इज प्योरली रियल, ए कॉम्प्लेक्स नंबर z इज प्योरली रियल व्हेन इट्स इमेजिनरी पार्ट इज जीरो, रियल व्हेन इमेजिनरी पार्ट, imaginary z equal to what? 0. Imaginary z is equal to what? 0. So what is the imaginary z here? 1 by twice I z minus z bar equal to what? 0. From here z minus z bar equal to ये twice I इधर जाके twice I into 0 क्या होगा? 0 हो जाएगी, and which equal to ये z bar इधर जाएगा, z bar equal to क्या हो जाएगी? z. Very important result is that if z is purely real, what is the condition? The condition is what? Z bar equal to what? Z. Whenever if you prove that z bar equal to z, then you can conclude that the complex number is purely what? Real. So under what condition a complex number is purely real? The conjugate of the complex number is equal to the complex number itself. Okay. Next point, if z is purely imaginary, then when a complex number is purely imaginary, when its real part equal to 0, real part means a, that means real z equal to 0, then real z equal to what? 0. From this result, what is real z? Real z is equal to what? Half into z plus z bar equal to what? 0. And you can conclude that z plus z bar equal to what? 0. This is a very important condition. When you add a complex number with its conjugate, complex number के साथ उसका conjugate अगर add करेंगे, then if you get the result is 0, then you can conclude that the complex number is purely imaginary. और अगर complex number purely imaginary हो तो ये result होगा दोनों vice versa. Okay, result will be vice versa. Means what? If the complex number is purely imaginary, then z plus z bar equal to 0. Or if z plus z bar equal to 0, then you can conclude that z is purely imaginary. Similarly, if z is purely real, then you get z bar equal to z, and if you get z bar equal to z, then you can conclude that z is purely real. That means vice versa, if and only if condition is satisfied. Okay, if this, then this, and if this, then this. Similarly, if this condition satisfies, then you get the result, and if this condition you get, you can conclude that z is purely imaginary. I hope you understand. These are the very important results. Okay. So what is imaginary z? What is real z? What are the conditions we have deduced? And this condition will be very useful in solving the questions. Question को आसान बनाने के लिए, easy करने के लिए ये property हम use करके problem को solve करेंगे. ठीक है? So let us going for next important results. Next important result, that is I am going to discuss. I hope you are understanding, and please go through the videos thoroughly such that you can understand. Okay, you can understand. Okay, next property. These are the actual property, and another important property already I have discussed, that is called z into z bar equal to what? Real z whole square plus imaginary z whole square. Why this is? Just I remind you. Okay, already I prove it actually. If suppose z is equal to what? A plus ib देन जेड बार इक्वल टू व्हाट, जेड बार इक्वल टू व्हाट, ए माइनस आई बी। ठीक है, दोनों को प्रोडक्ट कीजिए, जेड इंटू जेड बार इक्वल टू व्हाट, ए प्लस आई बी इंटू व्हाट, ए माइनस आई बी। आई होप यू आर अंडरस्टैंडिंग। एंड विच रिजल्ट इज व्हाट, ए स्क्वायर प्लस बी स्क्वायर, ये तो हम लोगों ने प्रूफ किया। एंड व्हाट इज ए, ए इज व्हाट रियल पार्ट ऑफ जेड एंड बी इज व्हाट इमेजिनरी पार्ट ऑफ जेड। वेरी वेरी इंपॉर्टेंट थिंग इज दैट बी नॉट आई, आई को छोड़ के जो बी कोफिशिएंट होती है, आई का कोफिशिएंट, दिस इज इमेजिनरी पार्ट, नॉट आई बी। मेनी ऑफ यू कंसिडर आई बी एज एन इमेजिनरी पार्ट, इट इज रॉन्ग, बी इज द इमेजिनरी पार्ट। ओके, so what is a equal to what, the real z whole square, okay, and what is b, imaginary z whole square. So this is an important result, okay. Whenever you product two complex number, तो आप क्या करेंगे, रियल z को होल स्क्वायर करेंगे प्लस इमेजिनरी z को होल स्क्वायर करेंगे, तो आपका आसानी से रिजल्ट निकल के आएगी। ठीक है, now we are going to discuss about very important thing that is called modulus of a complex number. Okay, modulus of a complex number. Almost there is important results of conjugate we have already discussed. सारी important point को discuss कर लिया है। अभी क्या करेंगे, modulus के बारे में थोड़ा सा, what is modulus? Like already you got in a real number, you get a real number. Suppose that this is a real line, this is what 0, this is 1 and this is 2. Okay, suppose that, okay, this is minus 1 and this is minus 2, okay, and there are infinite number of real numbers in the right and there are infinite number of real numbers in the left of 0, okay, and if you take x is any real number, then modulus of x is always what, greater than equal than 0. It represent a positive length, it represent a positive distance, it represent a distance and which is always positive. If I say this length is what, 1, okay, means its magnitude is what, this. If I consider this length is 2, then this is the actual representation modulus of 2. If I say this length is what, that is from here to here, if I calculate the length, मुझे distance चाहिए, then what is the distance from here to here, it is minus 2, the modulus minus 2. That means ultimately it is equal to what, 2. That means if you take modulus of a particular real number, it becomes a non-negative real number. Non-negative why I say, because sometimes if you say modulus of 0, इस point में ले ले, this is initial point, I am not moving in this direction or not moving in this direction, therefore distance is what, 0, and therefore modulus of 0 equal to what, 0. Okay, understood. Modulus of 0 equal to what, 0. That's why modulus of x is greater than equal than 0. Whenever this symbol is there, you say this particular quantity is non-negative. ये negative नहीं है, negative नहीं है. Whenever you say like that, suppose that you get x is greater than 0, then you can say x is a positive number. X is a positive number, whatever real or integer, whatever be, okay. And if x less than 0, you can say x is a negative number. And when x is greater than equal than 0, you say it is not negative, not positive. If you say non-negative, ये तो negative नहीं है, 0 से शुरू हुआ है, it is not negative, 0 plus all positive, okay. That's why it is called non-negative condition, okay. So modulus of x is a what, non-negative quantity. It is a non-negative quantity. Likewise in complex number, there is a absolute value of, this called absolute value, okay. एब्सोल्यूट वैल्यू है, यू नेगेटिव नंबर का एब्सोल्यूट वैल्यू क्या है, प्लस पॉजिटिव नंबर का एब्सोल्यूट वैल्यू क्या है, तो ये दैट पर्टिकुलर नंबर जैसे एब्सोल्यूट वैल्यू, एंड कॉम्प्लेक्स नंबर का भी एब्सोल्यूट वैल्यू होती है. सो यह वी आर गोइंग टू फाइंड दिस पर्टिकुलर कॉम्प्लेक्स नंबर. ओके, वी ऑलरेडी व्हाट represent the complex number in the eigenplan. Okay, suppose that a complex number z which is equal to what, a plus ib, and we already told you that it is equivalent to a point AB, like that, right? And along x-axis, it is called real axis, it is called what, imaginary axis. Okay, this is origin, and this distance is called A, distance is called what, B. And along x-axis, you are plotting what, real part, and along y-axis you are plotting what, imaginary part. आपको क्या करना है, x-axis में real part plot करना है, and y-axis में क्या करना है, y-axis के direction में imaginary पार्ट प्लॉट करना है कॉम्प्लेक्स नंबर का, तब जाके आपको ये कॉम्प्लेक्स नंबर मिलेगी। इफ़ आई सपोज draw a line from origin to this, suppose this is the point P. P is a point representing this complex number. P is a point representing a complex number in the argand plane, in the what argand plane. Now this is a 90 degree, okay, and hence it is a right angle triangle. From this right angle triangle, what OP square is equal to what? A square plus B square, ठीक है, and from here OP equal to what? Square root of what? A square plus B square, ठीक है। ये जो OP होती है, ये OP क्या है? डिस्टेंस फ्रॉम द ऑरिजिन टू द कॉम्प्लेक्स नंबर, डिस्टेंस फ्रॉम द ऑरिजिन टू द कॉम्प्लेक्स नंबर। समझ में आ रहा है? दिस इज कॉल्ड दिस डिस्टेंस इज कॉल्ड डिस्टेंस फ्रॉम द ऑरिजिन टू द complex number, and distance from the origin to the complex number is OP, and which is denoted by this symbol, denoted by what? Symbol, and it is called modulus of the complex number. So modulus of the complex number is what? A square plus B square, ठीक है। And what is A? A is what? Real part, and B is what? Imaginary part. Real part is square plus imaginary part is square, okay. So this means modulus of Z is what? You now geometrically you can understand, आपको समझ में आना चाहिए what is modulus of Z. Modulus of Z is a quantity which represent a distance. What type of distance? Distance from the origin to the complex number. डिस्टेंस फ्रॉम द ऑरिजिन टू द कॉम्प्लेक्स नंबर, ये ओरिजिन से कॉम्प्लेक्स नंबर तक जो डिस्टेंस है, ये डिस्टेंस है। इफ़ आई कंसीडर ए कॉम्प्लेक्स नंबर हियर 2 - 3i, so it is representing what? It will lies in what? I'm sorry, -2 plus 3i, then x नेगेटिव y पॉजिटिव, a नेगेटिव y, तो a नेगेटिव होगा y पॉजिटिव होगा तो कॉम्प्लेक्स नंबर इधर होगा। तो व्हाट इज द मॉडुलस? दिस इज द मॉडुलस, दिस इज द मॉडुलस। मॉडुलस ऑफ z क्या होगा? यू सी दिस इज़ वाट -2 एंड दिस इज़ वाट 3, तो ये पाइथागोरस लॉ यूज़ करें, क्या होगा? -2 होल स्क्वायर प्लस 3 स्क्वायर, ओके। एंड दिस इज डिस्टेंस ऑफ, सपोज दिस इज द पॉइंट P, एंड P रिप्रेजेंटिंग द कॉम्प्लेक्स नंबर 2 -2 plus 3i, तो क्या होगा? ये अगर Z है, दिस इज द कॉम्प्लेक्स नंबर Z, देन मॉडुलस ऑफ Z इक्वल टू वाट? माइनस ये स्क्वायर रूट होगा, इसका डिस्टेंस क्या होगा? -2 होल स्क्वायर प्लस 3 स्क्वायर, so equal to -2 whole square plus 3 square. So the complex number lies in any quadrant, first quadrant or second quadrant or third quadrant or fourth quadrant. Modulus means what? Distance from the origin to the complex number. Complex number ये जो आर्गन प्लान में रहेगा, इस आर्गन प्लान में जो रहेगा, उस आर्गन प्लान में कोई भी क्वाड्रेंट में रहे, फ्रॉम दिस क्वाड्रेंट की कोई पॉइंट से ओरिजिन तक जितना डिस्टेंस है, ये डिस्टेंस का नाम क्या है? मॉडुलस ऑफ द कॉम्प्लेक्स नंबर। दिस सिंपल, ओके। So what will be definition? If Z is equal to A plus IB is a complex number, okay, then modulus of Z is denoted by this symbol modulus Z, and defined as modulus of Z equal to what? √A square plus A square, ठीक है। आपको समझ में आ रहा है, ठीक है। इफ Z is equal to A plus IB is a complex number, then modulus of Z is denoted by the symbol this and defined by this. Why it is defined by this? Because from the figure it is clear, okay. So whenever I say modulus of a complex number, in your mind it means you visualize, आपको visualize करना पड़ेगा कि ये क्या है, origin से complex number तक क्या है, distance है, and complex number is denoted by a point, so very simple, okay. Now we are going to discuss about very important properties of modulus of a complex number. मॉडुलस ऑफ ए कॉम्प्लेक्स नंबर प्रॉपर्टी हम डिस्कस करेंगे अभी, ठीक है। I hope you all are understanding, you are enjoying the class. Very interesting chapter, and it's really helpful for entrance examination also. So this results is very useful because your basic is strong. You can solve difficult problems very easily. Okay. Suppose that z is equal to what? A plus ib is a complex number. So what is the modulus of z? Modulus of z is equal to what? Root over a square plus b square. Okay. Now what is z bar? Conjugate of this complex number is equal to what? A minus ib. ठीक है. Then what is the that is conjugate of z bar? Conjugate of z bar equal to what? Root over. Real part is what? A. And what is imaginary part here? You very important. Always represent the complex number into the standard form a plus ib. बीच में प्लस होना चाहिए. ठीक है. बीच में क्या होना चाहिए? प्लस होना चाहिए. So it can be written as what? You see a plus minus b into I. Yes or no? Minus b into I. So real part is a and imaginary part is what? Minus b. So a square plus minus b whole square, and which is equal to root over what? A square plus b square. Okay. And this one and that one both are what? Same. Means what? Modulus of z and modulus of z bar are always same. That means if you take the you can take the conjugate of a the modulus of a conjugate complex number, you will get the same complex number. That is, आपको क्या मिल रहा है? z bar magnitude modulus of z bar equal to what? z. दैट मीन क्या होती है? कोई भी कॉम्प्लेक्स नंबर के ऊपर अगर बार रहे, उसका अगर मॉडुलस लिया जाए तो मॉडुलस क्या हो जाता है? रिमूव हो जाती है. दैट इज़ द प्रॉपर्टी. मॉडुलस क्या हो जाती है? रिमूव हो जाती है. तो इफ़ आई से z1 प्लस z2, इफ़ आई राइट लाइक दैट बार मॉडुलस, तो आप क्या लिख सकते हो? यू कैन राइट z1 प्लस z2 मॉडुलस. इसमें बार क्या होगा? ये बार क्या होगा? कैंसिल हो जाएगी. सो this particular property can be utilized in this manner. Okay. So another property of conjugate के साथ मॉडुलस का जो रिलेशन है वो बहुत इंपॉर्टेंट है. z into z bar. z into z bar equal to what? We already got z into z bar equal to what? A square plus b square. A plus ib into a minus ib equal to what? A square plus b square. And modulus of z equal to what? Root over a square plus b square. ठीक है. And what will be modulus of z whole square? Modulus of z whole square is equal to what? A square plus b square. दोनों में स्क्वायर करें. ठीक है. अभी तो modulus of z whole square is equal to what? A square plus b square. Z into z bar equal to what? A square plus b square. So both are same. Therefore this is equal to what? This. Therefore you can say modulus of z whole square is equal to what? Z into z bar. Very important results. Very important. Excellent. Okay, ये बहुत ही important है. From here you can write yes, ये एक बहुत सा important result है. जैसे मैं कहूँ suppose that z plus 1 modulus, ये एक complex number. z is a complex number, so z plus 1 is a complex number. Okay, तो उसको हम expansion कैसे कर सकते हैं? z plus 1 into z plus 1 bar. ठीक है. Utilizing this particular result. So sometimes in questions we will get such type of results. तो to expand this type of result क्या करेंगे? ये फॉर्मूला यूज़ करेंगे. अंडरस्टूड? ये फॉर्मूला यूज़ करेंगे. ठीक है. z plus 1 into z bar plus 1. Since 1 is a real number, तो रियल नंबर के ऊपर अगर बार दिया जाए 1 बार इक्वल टू 1, 2 बार इक्वल टू 2, तो रियल नंबर के ऊपर बार देने का मतलब नहीं. लेकिन ये जो बार कैंसिल करेंगे इट विल बी व्हाट? That is what formula I have applied? It is applied by z1 plus ये अप्लाई किया गया इसमें. ये कॉम्प्लेक्स नंबर z1, सपोज z इक्वल टू z1 and z2 equal to what? 1, because every real number is a complex number, so it is also considered as a complex number. So it will be z1 bar plus z2 bar. Okay, and what is z2 bar here? z2 is equal to what? 1. तो 1 के ऊपर बार देने के बाद क्या होगा? ये 1 ही रह जाएगी. तो that's why I am removing bar here. So in this way we can utilize this particular result. Okay, हमें ये रिजल्ट कैसे प्रॉब्लम में यूज़ करना है, एक एग्जांपल मैंने दिया है, ऐसा यूज़ कर सकते हैं. ठीक है. Now I am going to discuss about properties of modulus. Okay, there are two important properties That is, first property is if Z1 and Z2 are two complex numbers, then modulus of Z1 into Z2, that means product of two complex number you take, and if you take their modulus, then modulus can be separated. That means modulus of Z1 into Z2 can be written as a what? Modulus of Z1 into modulus of Z2. Similarly, modulus of Z1 by Z2 is equal to what? You can separate the modulus also, modulus of Z1 divided by modulus of Z2. Okay. This particular number 1 that is property can be modified also if suppose Z1 equal to Z2 equal to what? Suppose Z, अगर Z हो तो क्या होगा? तो इट विल बी ये लेफ्ट हैंड साइड क्या हो जाएगी? Z1 is Z, Z2 is Z, Z into Z means what? Z square. Modulus of Z square is equal to what? It is what? Modulus of Z. It is what? Modulus of Z, and it will be what? Modulus of Z whole square. That means a formula is developed. Modulus of Z square is equal to modulus of Z whole square. Okay. Similarly, it will be considered, suppose if the power is cube, modulus of Z cube is equal to what? Modulus of Z whole cube. Okay. So finally, modulus of Z to the power n equal to what? Modulus of Z whole to the power n. Okay. So this particular result is deduced from this particular property. Okay. ये property से ये formula हमने develop किया है. ये भी हो सकता है, Z cube लो तो Z cube हो सकता है. Then basically this is the formula. This is the particular result we get. So any type of power is given, Z square, then modulus of Z whole square, Z cube, then modulus of Z whole cube, Z to the power 4, then modulus of Z whole to the power 4 in this way. Okay. So you can do like that. Now we discuss few properties, and now we are going to solve few questions related to this particular properties. One important concept I am going to discuss, that is called multiplicative inverse. Multiplicative inverse of a complex number. Okay. What actually multiplicative inverse is? Suppose that 2 is a number. What is the reciprocal of 2? Reciprocal of 2 is what? 1 by 2. If you multiply it, then result is what? 1. Result is equal to what? 1. In such cases, half is called multiplicative inverse, MI, I am saying MI, multiplicative inverse of 2. Because multiplication is there, that's why it is called multiplicative inverse. Okay. Half is called inverse of what? 2, and it is called multiplicative inverse of 2. जैसे मैं कहूँ √3. What is the multiplication of multiplicative inverse of √3? This is a multiplicative inverse of 2 is what? 1 by 2. What is the multiplicative inverse of √3? It will be what? 1 by √3. Okay. Now if Z is a complex number, then what is the multiplicative inverse? It is what? 1 by Z. Z into 1 by Z is equal to what? 1. Okay. And 1 is also complex number, and it is called unit. It is called identity. It is called what? Identity. Okay. 1 is called identity here. It is called multiplicative identity. It is called multiplicative identity. So Z is a complex number. 1 by Z is called what? 1 by Z is called multiplicative inverse of this complex number Z. ठीक है. So let suppose that Z is equal to what? A plus IB, a complex number. Then multiplicative inverse of Z is 1 by Z. Okay. And 1 by Z equal to 1 by A plus IB. whenever any complex number is there, कोई भी complex number हो तो आप क्या करेंगे, उसको a plus ib में स्टैंडर्ड फॉर्म में कन्वर्ट करना पड़ेगा. 1/a plus ib is not in standard form. We have to reduce into what? This form, a plus ib. इस फॉर्म में कन्वर्ट करना पड़ेगा. So for this what we will do, we will modify this particular complex number. Okay, we modify this particular complex number. Now how to modify this complex number? Whenever there is a denominator, denominator क्या है, a plus ib है. सो मैंने आप लोगों को कहा था डिनोमिनेटर में अगर कम्प्लेक्स नंबर है तो उसके साथ क्या मल्टीप्लाई करना है, उसका कंजुगेट a प्लस आई बी इंटू a माइनस आई बी. एंड सिंस यू मल्टीप्लाइड डिनोमिनेटर बाय a माइनस आई बी, सो सेम अमाउंट इज ऑल्सो मल्टीप्लाइड इन न्यूमरेटर. दिस रिजल्ट इज इक्वल टू व्हाट, a स्क्वायर प्लस b स्क्वायर, एंड दिस इज व्हाट a माइनस आई बी. ओके, since z is equal to what, a plus ib, so what is z is equal to a plus ib, and therefore modulus of z is equal to what, root over a square plus b square, by according to the definition of modulus. Okay, z is equal to a plus ib, so modulus of z is equal to what, root over a square plus b square. Then if you squaring both sides, you will get modulus of z whole square equal to what, a square plus b square. And again z is equal to what, a plus ib implies z bar equal to what, a minus ib. I hope you understand. So from this result can be written as, this is written as what, z bar, and this is written as what, modulus of z whole square. And therefore you can say 1 by z equal to, 1 by z is equal to what, z bar divided by what, modulus of z whole square. So finally what you get, that is multiplicative inverse mi, in short I am written multiplicative inverse of z equal to what, any complex number z is equal to what, z bar by modulus of z whole square. So whenever a question come, find the multiplicative inverse of any complex number, so you have to find z bar and modulus of z whole square, and using this result you can find a multiplicative inverse. So take a simple example. Take a simple example. You will get, for example, suppose that z equal to 3 plus 4i is a complex number. Okay, so z is equal to what, 3 plus 4i. So you have to find multiplicative inverse of z. Your question is what, to find multiplicative inverse of z. Then how to find, to multiplicative inverse of z, you use this formula to find z bar first. Therefore z bar equal to what, 3 minus 4i, and modulus of z whole square is equal to what, a square plus b square. What is a, 3, what is b, 4. So a square plus b square is equal to कितना मिल रहा है, 25, and therefore multiplicative inverse of z equal to what, z bar divided by modulus of z whole square, and z bar is what, we get 3 minus 4i, and this is what, 25, and which can be written in standard form, 3 by 25 minus 4 by 25i. Okay, so this is the way you have to find the multiplicative inverse of a particular complex number. ठीक है, so I have discussed few concepts related to this particular chapter, that is called what, complex number, and here I have discussed today, that is called properties of conjugate, and then properties of that is modulus, and also what is modulus of a complex number, and then multiplicative inverse, and also some important results regarding what, conjugate of a complex number. Okay, so you have to go through all these properties and all the important points. I believe that you can build a a beautiful concept regarding this particular topic. And when your conception will be clear, definitely you can solve any problem. And in the next class, I am going to start to solve the questions, okay? And important question I will solve, and few questions I will give as a homework to you. And please do that, and you please try your own to solve the homework. And if you depend more on teachers, then whatever, your confidence will not build. Let us you try yourself, and also you discuss among your friends and solve the particular questions. I hope you will do it and you will get confidence in the subject. And maths is not a difficult subject, it is easy one, and take it in a very positive way. It is a practical subject, so you have to involve practically and solve the problems. With all the best, I conclude here. Thank you very much. In the next class, I will solve questions regarding this particular chapter. Thank you.